Hi everyone, my name is Rupa and I'm the VR product management lead, and I'm so excited today to walk you through an overview of Meta Quest Pro. Over the lifetime of Meta Quest 2, we've received some great feedback from customers about all the things they want to do with VR that aren't possible today. It's this very feedback that has inspired the innovations in Meta Quest Pro. So, what exactly is Meta Quest Pro? Well, it's a brand new premium VR headset that is fundamentally different than Meta Quest 2 and brings some of the most advanced VR capabilities that we've ever shipped, which opens the door for you, the developer community, to build some exciting new things. So let's cover some of those. Being fully immersed is great for gaming and entertainment. But when you're using VR for other purposes such as reading or working, you want to have the context of your surroundings. Like maybe you want to multitask at a virtual workstation with multiple resizable screens all around you. But you need to be able to see your physical desk and keyboard and maybe take some notes, or when someone walks in the room so you can say hi. On Meta Quest Pro, the pass-through API that we released earlier this year on Meta Quest 2 rises to a whole new level with high-resolution color. Meta Quest Pro's high-resolution outward-facing cameras have 4 times the number of pixels as Meta Quest 2's cameras, enabling the headset to recreate the environment around you in VR with greater fidelity. This works together with advanced reconstruction algorithms that triangulate the location of 3D points in the room that are sensed by cameras. Meta Quest 2 has started to capture the vision of how we can be more social in VR. But even though people are having incredible experiences getting together in VR today, they want these connections to be even deeper and richer and to give them that feeling of presence in the metaverse. So, with the new inward-facing sensors in Meta Quest Pro, you can have your avatar mimic your natural facial expressions and nonverbal communication in real time. Picture a creative writing team who gathers in workrooms to sketch out some ideas where they can see their colleagues interact with one another as if they're collaborating in the same room. The headset's ability to understand your face and eyes can also enable other helpful features, such as detecting whether your headset is properly fitted and help you make those adjustments if needed. Using a technology called eye-tracked foveated rendering, this device can ensure that the image is at its best resolution right where you're looking on the screen. These features will all be made available to you via an SDK, and you can learn more about it in the Performance and Optimization on MetaQuest platform session coming later today. We slimmed down the optical stack by over 40% compared to Meta Quest 2 using our innovative, patented pancake lens and optics technology, which works by folding light inside the optics module. This new type of lens isn't just way thinner, but it also enables sharper, clearer visuals, which makes reading text in VR a lot easier. When combined with our advanced VR LCD display technology, which provides 37% greater pixels per inch, 10% greater pixels per degree, we get 25% improvement in full field visual sharpness in the center view and 50% improvement in the peripheral region when compared to Meta Quest 2. Our specialized local dimming technology allows us to control over 500 individual LED blocks independently, delivering 75% greater contrast compared to Meta Quest 2. The improvement in contrast with 1.3 times larger color gamut provides more vibrant colors to deliver a more engaging VR experience. Advanced optics and a continuous IPD accommodation adjustment allows the headset to accommodate a wider range of IPDs than Meta Quest 2. All of these features together unlock opportunities for text-heavy content that's suited for productivity. Meta Quest Pro's battery is moved to the back of the headset to create more counterbalanced ergonomics using our first ever curved cell battery to better conform to the head. And you'll notice Meta Quest Pro is much slimmer than Meta Quest 2 in the front, In the back, there's a fit wheel for precise adjustment. And you can also adjust the level of immersiveness with the open periphery design, or choose to use the included partial light blockers. Or, in the near future, purchase full light blockers for a completely immersed experience. This comfort and flexibility of MetaQuest Pro enables customers to use the VR headset for a variety of use cases beyond just gaming. At Meta, we are very conscious of our users' privacy, and we expect developers for our ecosystem to take consumer privacy seriously also. As part of our focus on protecting consumer privacy, all MetaQuest Pro developers must abide by the requirements in Meta's developer data use policy to help ensure applications are developed with the appropriate protections for user privacy. We'll learn alongside developers what the future of VR will look like. Use cases that catch on with this new high-end line of devices will inform what features and content we invest in for our entry-level line of devices too. Our strategy is for these two lines to complement each other as they both add up to the forward progress of VR. And with that, it's my pleasure to introduce you to AR to continue the journey and discuss the all-new MetaQuest Pro controllers.
Thank you, Rupa. My name is A.R. Schleicher. I'm a developer relations engineer, and I've been working with many of our partners developing apps for the MetaQuest Pro launch. Today, it's my pleasure to introduce the details of the MetaQuest Touch Pro controllers to everyone. The MetaQuest Touch Pro controllers represent our most powerful VR controllers to date. Most importantly, the Touch Pro controllers are self-tracked, and this allows us to remove the tracking rings, resulting in a significantly smaller form factor. Developers no longer need to design around tracking constraints, and users never have to think about tracking. It just seamlessly works. The 3 cameras, combined with a CPU up to 80% as powerful as a Quest 1, handle tracking, allowing the headset to focus on other work. The Touch Pro controllers represent a big step forward in terms of haptic capabilities. Unlike previous touch controllers, which contain a single linear resident actuator, or LRA haptic device, the Touch Pro controllers contain 3 haptic devices. One primary voice coil motor, or VCM, haptic device in the main body of the controller, and 2 LRA haptic devices, one in the index trigger and one in the new thumb rest. The LRA haptic devices allow you to deliver haptic feedback at the location that most makes sense. Meanwhile, the VCM haptic device allows for the most complex and realistic haptic effects we've ever had via their ability to play audio-like PCM data. The index trigger is another area of significant improvement. In addition to the LRA haptic device, the trigger now contains sensors to detect finger curl and slide. Curl represents how open or closed your index finger is before touching the trigger. Slide represents how far to the inside or outside the point of contact between your finger and the trigger is. As you can see in this video, the movement of the user's index finger is translated into VR more accurately than ever before. The thumb rest is another area where we've added functionality to the Touch Pro controllers. In addition to the LRA haptic device, the thumb rest also contains a pressure sensor, allowing applications to determine how much pressure, up to about 6 newtons of force, is being applied. When combined, input from the index trigger and thumb rest can be used to enable a precision grip interaction. Precision grip enables a natural and intuitive pinch interaction in VR. In addition, precision grip also enables a secondary interaction of applying pressure to held objects. While the raw data involved in this calculation will be available at launch, we'll be introducing an API for developers in future SDK updates that makes calculated pinch amount and pinch pressure values directly available. Speaking of future SDK updates, since the MetaQuest Touch Pro controllers are self-tracked, it's also possible to enable simultaneous tracking of hands and controllers. While not available yet, this means that in the future, developers will be able to build new experiences using any combination of hands and controllers at the same time. We'll be introducing APIs and capabilities for this in future SDK updates. Next, while the Touch Pro controllers come with the lanyards we're all familiar with, these lanyards are removable and replaceable with stylus tips. These connect with a pressure-sensitive sensor in the base of the controller. Once you flip the controller around, this allows you to use the Touch Pro controller as a pen-like device in applications that support it. It's pressure-sensitive as well, measuring up to about 2 newtons of force. The stylus tip improves the writing experience by enabling accurate contact point detection with real-world surfaces. Surfaces like desks and walls, of course, but this can also apply to any object, allowing you interactions like tracing objects into VR. For developers, the support for the Touch Pro controllers is easier to implement than ever before. Since Connect last year, we've added new APIs and helpers, such as Get Current Interaction Profile and OVR Runtime Controller. Get Current Interaction Profile allows developers to determine whether the user is using Touch or Touch Pro controllers. OVR Runtime Controller allows developers to request appropriate controller models from the operating system, future-proofing applications by not only allowing them to render the correct models today, but also in the future with new hardware without an application update. Finally, it's important to note that the Touch Pro controllers are not just for MetaQuest Pro. The Touch Pro controllers are also available as a standalone upgrade for the MetaQuest 2 at an MSRP of $299.99. If you're looking for an upgrade for your VR gaming experience, consider these instead. Well, there you have it. All the details about the MetaQuest Touch Pro controllers. The freedom granted by no longer having tracking rings and not needing to keep the controllers inside the area the headset can see is a major improvement. Combined with the new inputs, the stylus, the thumb rest, the index trigger, and the new haptic devices, the LRAs for the thumb rest and trigger, and the VCM for the main hand, this controller is a major upgrade from the original Touch controllers. Either included with the MetaQuest Pro, or available as an upgrade for the MetaQuest 2 for $299.99. Pre-order yours today. Now let me introduce you to Prabhu, here to talk about how developers can use Presence Platform to build compelling new experiences for the MetaQuest Pro.
Hi, I'm Prabhu, the lead product manager for Presence Platform at Meta Reality Labs. Last year at Connect, we launched Presence Platform, our suite of machine perception and AI capabilities that enable developers to build mixed reality experiences and incorporate natural interactions like hand gestures and voice experiences into apps. As Rupa mentioned earlier, MetaQuest Pro is the first in our new line of advanced and high-end VR devices. To build the kinds of experiences that take full advantage of the groundbreaking technology in MetaQuest Pro, Presence Platform will deliver a suite of upgraded and new capabilities this year. To begin with, all the apps that our developers create for MetaQuest 2 using Presence Platform will also run on MetaQuest Pro. At launch last year, Presence Platform had two technology pillars that we opened up to developers: mixed reality and our interaction services, which includes hand tracking and voice. These two pillars will now also power experiences on MetaQuest Pro. To harness the new superpowers of this device, we are adding a third pillar today: social presence. Movement SDK is a brand new offering composed of our movement and natural expression capabilities, including eye, face, head, and controller tracking, unlocking a new dimension of presence in VR. If you want to build for enhanced social presence unlocked by MetaQuest Pro, Movement SDK is one set of capabilities you need to get started. With MetaQuest Pro's inward-facing sensors and the new Movement SDK, developers can create much more expressive avatars in real time, mimicking your natural expressions and body language to create a sense of presence. To learn more about bringing natural expression and realistic avatars to your characters, check out the dedicated developer session on Movement SDK. With our mixed reality capabilities, developers can create experiences that blend your physical world with virtual experiences, opening up new opportunities for unique digital experiences while staying present in your own space. Pass-through enables developers to build experiences that can blend the virtual content with the physical world. Spatial anchors enable developers to place persistent world lock content like animated holograms or your Instagram feed in your real space. And with our new shared spatial anchors capability, developers can unlock a whole new world of co-located multiplayer experiences. Scene understanding allows developers to semantically and geometrically understand the shape, location, and class of physical elements, such as walls, floors, a desk, or a couch around a user's physical environment. Combining pass-through anchors and scene allows developers to create room-scale mixed reality experiences. For example, developers can anchor a virtual screen on a wall or create virtual objects with realistic occlusion that interact with the environment around them. So, when you throw a virtual tennis ball against a real wall, it bounces back right at you. You can learn a lot more about what we are doing in mixed reality in the Presence Platform Mixed Reality Developer Session. With MetaQuest Pro, we are taking full advantage of the device's advanced sensor package, enabling mixed reality in higher fidelity and full color. Pass-through feels more natural than ever before, unlocking a rich new set of mixed reality experiences. We gave these capabilities to our internal teams, and they prototyped this really cool fencing demo. This demo isn't shipping just yet, but it shows what's possible once developers can build for a mixed reality headset. With our interaction pillar, we envision a future where you can move freely in the metaverse as you would in the physical world. Your hands, your voice are key inputs to feeling more connected and present in the metaverse. Our re-architected hand tracking capability, which we shipped earlier this year, opens up the use of hands in applications that require robust tracking and more complex gestures, like in games with fast hand motion, interactions between hands, or custom gestures. And with Interaction SDK, our Unity library of hand interaction components, gestures, and tools, we are making it easier than ever before for developers to integrate hands and controller-centric interactions into their experiences. For a deeper dive into hands, check out our developer session on Presence Platform input capabilities. Our voice capabilities allow developers to integrate voice input into games and apps so they can create new gameplay and navigation. This fall, we are bringing Voice SDK support to Unreal developers. I'm also very excited to share the beta release of Composer for Wit.ai and for Voice SDK in Unity, allowing developers to support rich conversations in an easy way. For details on how you can easily integrate voice into your experiences, do check out the developer session on Voice SDK. We strongly believe in the role audio plays in creating immersive VR experiences. To make it easier for our developers to build rich, immersive audio into their apps, we are excited to launch an audio SDK as part of Presence Platform. To learn more about the audio SDK and how you can use it to enhance your experiences, check out the developer session on the all-new audio SDK from Presence Platform. It has been a busy year talking to developers, understanding their needs, building the long-term foundations we need for developers to be successful, and of course, bringing so many new capabilities to market to make use of all the innovations in MetaQuest Pro. Hope you get a chance to tune into all these developer sessions we have for you on mixed reality, voice, hands, audio, and social presence. Now, to bring this all home, here is a fun demo built by a small team of talented developers using all the pillars of Presence Platform: mixed reality, interaction, and social presence, and possible only on the all-new MetaQuest Pro. Here is Slimeball. Thank you.
You ready to play?
Oh, yeah.
Hey, that's mine. Hello.
This is so fun.
One more?
Hi everyone, I'm Sarthak, Lead Product Manager at Meta. I'm here with my colleagues to share how to build next generation mixed reality experiences using the Presence Platform and MetaQuest Pro. You will learn about improvements to capabilities like pass-through, scene understanding, and an exciting new update that will enable developers to build co-located multiplayer experiences. Being able to see the physical world around you and blend it with virtual content opens up new possibilities for VR today. And it's a step towards our longer term vision for augmented reality. Like many in the industry, we call the ability to blend elements from the physical world into virtual experiences mixed reality, or MR for short. At Connect last year, we began the journey into mixed reality when we released Presence Platform. At launch, we provided 3 core capabilities: pass-through, spatial anchors, and scene understanding. I am very excited by the creative experiences we have already seen many of you build with mixed reality, like gaming, which adapts virtual content to the physical room for ultimate immersion, or superpowered in productivity by combining huge virtual monitors with physical tools like keyboards and mice, or unleashing 3D creativity by collaborating with your coworkers in the same physical space. Mixed reality opens up new opportunities to engage your users. Here's an early look at what Resolution Games is building with mixed reality. Meta Quest 2 gave us an early look at the potential for mixed reality. Meta Quest Pro takes things to the next level, packing 4 times the number of pixels to deliver high resolution color pass-through. And it includes improved sensors for understanding the space around users. With capabilities like scene understanding and anchoring, the objects in your room can become part of the virtual experience. I have Avinav here to tell us more about color pass-through.
Thanks, Sarthak. Hi, I'm Avinav, Product Manager at Meta. Pass-through enables you to build experiences that can blend virtual content with the physical world. Last year, we enabled pass-through in Presence Platform, and many of you created the first set of mixed reality experiences on Meta Quest 2. And now, with Meta Quest Pro, we're taking full advantage of the improved sensors, enabling pass-through in high-resolution color. Today, I'm here to share how you can bring high-resolution color pass-through into your apps on Meta Quest Pro. Pass-through API is available for OpenXR, Native, Unity, and Unreal development engines. And what's more, anything developers create for Meta Quest 2 using pass-through APIs will also run seamlessly on Meta Quest Pro. Let's dive in. You can composite pass-through layers with other VR layers using alpha blending. This allows you to define areas where pass-through is visible, adjust its opacity. You can create multiple layers of pass-through and choose the order in which they are composited. Take a look at how Cubism uses this. You can build apps with pass-through as a background with virtual objects on top, kind of like AR applications. The second capability is stylization. This provides you with the ability to make changes to the pass-through image attributes. You can customize pass-through using the controls in the OVR pass-through layer script by modifying the edge rendering filters, defining color maps, and applying contrast and brightness adjustments. Figmin XR is a great example of this. The third capability is surface projected pass-through. This allows you to specify the geometry onto which pass-through images are kind of projected. You can introduce windows into the physical world integrated with VR experiences. For example, you can project pass-through onto a stable depth surface, like a physical table, unlocking use cases such as interacting with keyboard, desktop objects like phone and pen.
Adding pass-through to your apps is one of the easiest ways to make VR more comfortable for your users. For example, with the pass-through mode in Gravity Sketch, I feel much more comfortable walking around my room and using my entire environment as a canvas for creativity in 3D. And I can still say hi to my colleague when he walks into the room without taking off my headset.
Indeed, Sarthak. Additionally, we have seen developers using pass-through to enhance productivity by combining virtual screens with physical tools. For example, with Immersed, users can spawn up to 5 virtual screens and program without distractions, or collaborate with others on virtual desktop. Seeing the real desk, keyboard, and mouse is now a breeze thanks to pass-through.
Thanks, Abhinav, for the overview of color pass-through. Going beyond pass-through, you've also seen many of you actively use scene understanding to create entirely new kinds of MR experiences that adapt to the user's personal space for the ultimate immersion. With me is Britta. She's going to tell us more about scene understanding.
Great to be here with you, Sarthak. Hey, I'm Britta, Engineering Manager at Meta. Earlier this year, we shipped spatial anchors, scene capture, and the scene model. And the creativity we have seen from you has been mind-blowing. From 3D creative apps to productivity to games, and even learning to play the piano. Here are a few quotes you shared. VR pales in comparison to designing a mixed reality game that takes place in the real world. And here's another. The scene capture starts automatically, making it almost effortless to start using the Scene API. But even more so, we appreciate your feedback and feature requests. So a huge thank you to all of our early adopters.
Let's start with a recap on spatial anchors.
Think of anchors as a way of pinning virtual content anywhere. For example, arrange your virtual screen around your table and know that they'll still be there the next day. Anchor resilience and recovery will continue to get better. For example, our recent update nearly doubled tracking resilience. Long-term, we're investing in deep learning, machine perception, and API improvements to make your anchors rock solid.
What do you think our developers should know about using the scene model?
All right, let's talk about the scene model then. Let me introduce this little critter, Serafino. We created him to demonstrate how you can convincingly blend the physical and the virtual worlds. See how Serafino is crawling around without walking through furniture? In order to do that, he needs to know the room's floor plan, including furniture. This is provided by the scene model. And see how he is being occluded here by the furniture? Also enabled by the scene model. To automatically move around, he needs a locomotion system. Our scene model can power both simple nav meshes and, as in Serafino's case, procedural animation. You could also manually steer Serafino across the wall and furniture like this. This is the scene model at work again. It makes him aware of the 3D geometry of the room. And see that little blob shadow here? Shadows are super important cues for humans. They add depth and a sense of realism. Scene model allows you to make plausible blob shadows. Now, won't you stay off that bed, Serafino? With semantic object labels like wall and table, which are also part of scene model, you can make sure he doesn't crawl up the bed like a good pet.
That's cool. Can you do physics too?
Yes. Remember Ape from last year? That's him now in high-resolution color pass-through on MetaQuest Pro. See how that virtual ball he's chasing bounces off the real wall? That's the physics engine at work, enabled by the scene model. And that multi-tools ray hitting the wall? This is raycasting, also enabled by scene model.
Got it. In order to build this experience with the scene model, we need a way to capture the environment around the user. This is where scene capture comes in. As a quick recap, scene capture is the system UX with which users can manually tag their walls and furniture. Britta, can you tell us more about what's coming next with scene capture?
Absolutely. We've heard you're eager to see how we're improving the scene capture flow for people. Beyond reliability improvements, in the coming months, we're making 3 upgrades to scene capture based on your feedback. 1. We're adding scene recovery to ensure people can reliably retrieve their scene model. This avoids the friction of a user needing to recapture their room. 2. We're also introducing on-demand capture. You can specify what objects you want to capture, details like 3 tables or a single door. And 3. We're going to add more types of scene elements that the user can capture, such as screens, shelves, and plants. And longer term, we will be focusing on capabilities that reduce user friction and make scene capture more seamless. We'll have more to share in the coming months.
That was great, Britta. Thank you. A big part of why we are building these capabilities is all about bringing people together. And here's Shalene to tell us more about how you can leverage MR to do exactly that.
Thanks, Sartek. Hi, I'm Charlene, Product Manager at Meta. Imagine being able to play a virtual game with friends and family in your living room. Seems simple enough, right? But it's actually a complex problem to solve, especially when you're dealing with the relative position of people and virtual content in the same space. We want to make these type of experiences easy for you to build. This is why I'm excited to announce Shared Spatial Anchors, an update to our Spatial Anchors capability in Presence Platform. We've heard that many of you want to build co-located multiplayer apps. It's an exciting new domain in mixed reality for both entertainment and collaboration. Gone are the days when co-located experiences could only be built with external sensors in a managed arcade-style space. You can now bring these experiences into people's living rooms. More specifically, Shared Spatial Anchors builds on the Spatial Anchors API by providing additional methods that allow users to start co-located sessions. You get new APIs to save and grant other users access to shareable anchors. Upon loading shared anchors, users are able to establish a common frame of reference, so people in the same physical space can see and interact with the same virtual content, unlocking co-location. You can build co-located experiences by combining pass-through, scene, and shared anchors capabilities in Presence Platform. Here you see a demo with co-located players. They all have a shared frame of reference and can share virtual content like crystals. What makes this fun is experiencing something magical in mixed reality with your friends and family right in your living room. This is an example from one of our early development partners, BeatShapers. It's a co-located game with remote-controlled tanks that you can play in your own home.
I'm excited by the new categories of co-located multiplayer games you can build.
That's right, and we're also excited to see how developers will bring co-location to productivity experiences. We're working on this too. For example, Workrooms has a project we call Magic Room to make collaboration engaging and productive. We believe shared spatial anchors will bring people together to socialize, collaborate, and have fun. Back to you, Sartek.
When you bring pass-through, scene understanding, and shared anchors together, you can create entirely new experiences. Today, we are also announcing a dedicated shelf for MR titles on the MetaQuest store, where we will promote select mixed reality experiences. We believe this will drive user awareness for MR. We are committed to making it as easy as possible for you to create MR experiences. To access documentation and sample code, visit Presence Platform on the web and get started. You will find OpenXR API documentation, Unity and Unreal plugins, guidance on best practices, source code for the world beyond, and other samples. And we will continue to support PC Link as a developer tool for mixed reality. This makes it easier for you to test and iterate on the PC without deploying to the headset. We have said before that experiences developers create will really shine when our hardware and software leap forward. With Presence Platform and MetaQuest Pro, people are going to experience the power of combining physical and virtual worlds in entirely new ways. We are excited by the enthusiastic support we have already seen from developers building mixed reality experiences. Together, we are taking one step closer to delivering the future, one step closer to the metaverse.
Hi, I'm Brett Gildersleeve, and as a product manager at Meta, my goal is to help developers use the power of audio to create a realistic sense of presence for people when they're in virtual environments. Immersive audio creates dimensionality, a sense of place, and even identity for users. So today, my colleague Henry from the sound design team and I will provide an overview of spatial audio and room acoustics and help you understand the role that these can play as you create immersive VR experiences. We'll also provide real-world examples of these features in action. Finally, we'll show you how easy it is to start building amazing audio experiences in your next app using Audio SDK, which will launch as part of the Presence platform soon. Presence platform is the collection of SDKs and APIs from Meta that provides developers with AI, machine perception, graphics, and audio capabilities to build immersive experiences that blend the physical and virtual worlds and help people connect with each other. When paired with MetaQuest devices, Presence Platform empowers developers to innovate and unlock new use cases with mixed reality, social presence, and interactions. What does it mean to hear sound in 3 dimensions? In real life, we don't just hear sound between left and right. We hear it behind us, in front of us, below us, and above us. Spatial audio is a big component of creating a similar experience in virtual reality. In order to understand the role spatial audio should play in the virtual world, we first have to think about how people perceive sound in the physical world. For starters, how do we understand where a sound is coming from using our ears alone? When sound waves approach the human ear in the real world, they hit each of our eardrums at slightly different times. First in the ear that's closer to the source of the sound, and then slightly later in the ear that's further away. Sound waves also get quieter with distance, so the sound is louder in the ear that's closer to the source, and a bit quieter in the ear that's farther away. These are some of the clues that the brain uses to figure out where a sound is coming from. On their own, though, these subtle differences in timing and level don't provide quite enough information. For example, imagine placing a sound source either at position A in front of us or position B behind us. Because these distances are equal, the brain can't make a distinction between the two. So, how do we figure this out? Well, for one thing, our heads are never really stationary. We're constantly making small, subtle movements. You can see in this diagram that as the person rotates their head slightly, the distances between the sound sources in each ear will change. The brain picks up on these tiny differences and helps us distinguish between front and back. In the same way, these micro movements can help us determine if a sound is coming from above us or below us. Beyond these differences in time and level at each ear, another major contributor to how we hear in the physical world is the way that sound waves interact with our bodies, particularly our outer ears. Sounds reflect off of us and bend around us, and this changes the way that they sound when they finally arrive at our eardrums. This is known as the head-related transfer function, or HRTF. The brain uses this combination of cues resulting from the HRTF, as well as the differences in time and level between the ears that we discussed earlier, to figure out exactly where a sound is coming from. In other words, human hearing is complicated. And in order to help people feel immersed in VR, they really need to hear things approximately like they do in the physical world. But the standard game engines we commonly use to build VR applications don't usually take all of these subtleties around spatial audio into account. That's because these game engines weren't specifically designed to build VR applications. They're usually more general purpose, allowing for games that run across a variety of devices, including PC, mobile, or consoles, and with speakers that are fixed in position and don't track the user's head movements. Now, these game engines actually have a lot of great audio features. They allow designers to place sound emitters at any point in 3D space, and when those sounds play, they're panned between the left and right speaker to help give the player a sense of left-right positioning, as well as distance. But this lacks some of the subtleties that we hear in the real world. And as a result, it won't do a great job in tricking your brain into feeling immersed in VR. The real power of VR headsets when it comes to unlocking convincing spatial audio is head tracking. We can use the position and orientation of a person's head to automatically adjust the time and level in each ear independently for each sound that is played back, as well as applying the HRTF. Together, this allows people to hear things in the virtual world in the same way that they hear them in the physical world. If you've ever listened to an album in mono and then experienced it again in stereo, you've probably recognized the qualitative difference that that extra dimension creates, and noticed details that you missed in the mono version. Spatial audio is the next evolution of this concept. Even though a VR headset might have a limited field of view, the auditory field of listening is a full 360 degrees. This gives the user peripheral awareness and allows them to understand where things are, even if they can't see them. This also makes the audio mix less cluttered, allowing people to hear more detail from individual sound sources, even when many sounds are playing all at once. If we look at this example scene, where we have sound sources above us in red, behind and below us in blue, and off to the side of us in green, if we build the scene in VR without spatial audio, everything will sound like it's roughly on the same plane, aligned with the user's head, as pictured here on the right. Without spatial audio, our sense of localization is relatively poor, preventing us from accurately judging the location of each source in 3D space. The sense of externalization, when using non-spatial audio in VR, is also poor, meaning that rather than sounds seeming to come from out in the environment, they tend to sound more like they're coming from headphones placed over our ears. Overall, without spatial audio, there's a mismatch between our eyes and our ears that just makes things feel less real. So, our ears can tell us where sounds are coming from thanks to spatial audio, but that's not all they can do. They can also tell us a lot about the environment that we're in. What kind of space are we in? An expansive cave? An open field? Padded cell? How big is it? What materials is it made of? Our ears can tell us all of this based on room acoustics. In the physical world, sound waves spread out from a source similar to how ripples spread across the surface of a swimming pool. While the waves that take a direct path to our ears are the ones we hear most prominently, countless others reflect off of the walls, ceilings, and floors and other objects in the room before they reach our ears. We call the waves that arrive first the direct sound, since they travel in a direct path to our ears. Those that arrive shortly thereafter, after bouncing off one or two nearby surfaces, are called early reflections. And the waves that bounce around many times before they reach our ears are called late reverberation. The materials of the walls, ceilings, and floor will reflect or absorb sound waves in different ways, which can change how these reflections sound to us. The brain is incredibly good at taking in all of this information and giving us an understanding of the physical space we're in, including the size, shape, and material properties of it. Think about it. If you close your eyes and clap your hands, you'll easily be able to tell if you're in a big carpeted living room or a small concrete bunker. So, how does this work in game engines? Well, similarly to spatial audio, game engines don't apply room acoustics by default. When you hear a sound in a game engine, the default behavior is to just play the direct sound. This gives you a feeling that you're floating in space. You have no sense of the environment that you're in. Because of this, adding artificial reverb to sounds has become pretty common practice in game development. But just applying any old reverb often leads to a mismatch between the way a room sounds and the way it looks. When this happens, especially in VR, people will get the sense that something is off. Using an analogy from the graphics world, we might get a similar feeling when we see shadows that don't correctly match the lighting in a scene. Using the wrong reverb can be immersion breaking, especially in VR apps. For example, a person might see a large room around them, but it still sounds like a small closet. There's actually a name for this in research literature, the room divergence effect. As you can see in this excerpt from a research paper on this subject, room divergence causes a collapse in the plausibility of the overall auditory scene. For the end user, this effectively means that it can break their suspension of disbelief. Luckily, we provide tools that will help you easily create room acoustics that correctly match virtual spaces. And this really makes virtual environments much more believable because our eyes and our ears won't be contradicting each other. Immersion is one of the goals of virtual reality, and the combination of spatial audio and room acoustics are vital in achieving this goal. When these are done right, we truly feel sonically teleported into the worlds we've created, rather than just observing them through a screen. With that in mind, to talk about some real-world examples of how we use these features in our own VR experiences, as well as help you get started with building your own, let me introduce Henry Halverson.
So Brett has covered a lot of spatial audio concepts and terminology. Now, how do we apply these in practice and really pull people into the virtual worlds we create? Hi, I'm Henry Halverson. As a sound designer at Meta for the past 3 years, I've used spatial audio tools to build high-fidelity audio experiences for our users. And I hope to share the benefit spatial audio has brought to our applications, as well as inspire you to discover and use these integrated audio tools in your own development processes. Highly immersive spatial audio will help you realize the full potential of your ideas when building apps with the Presence platform. You know, this isn't new territory for our team. We've created and refined spatial audio tools for many years on the Rift and Quest platforms. And now we plan to offer these same tools here in the Presence platform, along with various new features and improvements. Here at Meta, we've already implemented spatial audio and room acoustics in a number of different VR applications. Our app Horizon Workrooms is an excellent example. Workrooms is a VR space for teams to connect, collaborate, and develop ideas together. And audio helps make this experience feel real, allowing team members to speak with one another naturally, just as they would in person. In practice, this means if several team members are sitting around a table with you, you'll hear their voices all coming from the correct locations. This spatial separation is something we are inherently familiar with as humans, and allows our brain to more easily distinguish between voices. Workrooms also leverages audio directionality. So if someone is speaking towards you, they will sound clear. And if someone turns their head, their voice will be intelligible, but perceived as a bit quieter and less distinct, just as you would expect in the real world. Adding room acoustics to Workrooms helped make the environment feel more inviting. The room acoustics in Workrooms has been set up to mimic the geometry of the space and fine-tuned to make each space feel right. When these audio features are used well, people can make sense of a virtual space, even with their eyes closed. Spatial audio has been shown to make conversations more memorable and can improve comprehension. So let's jump in now with Brett and take a look at these features in action.
Hey, Henry, welcome to Workrooms. So, as we discussed earlier, spatial audio helps to localize my voice so it sounds like it's coming from here where I'm sitting. If you were to say, look out that window at the beautiful scenery, you should hear my voice coming from your left and behind you, kind of over your shoulder, just as you'd expect. Also, the room acoustics in here are set up to match the size and shape of this space, making it sound more natural. My voice is also directional, so if I were to say turn around and look at the whiteboard, you should hear my voice is a little bit muffled as I'm facing away from you, and it's more clear as I face back towards you.
Workrooms is an excellent example of spatial audio within a social context. These same audio implementation techniques will bring to life any experience you create when used in conjunction with other tools in the Presence platform. We encourage you to use spatial audio in mixed reality experiences to fill the space around you with sound. Use these audio tools with the Interaction SDK and create hands-first experiences without controllers that use audio to provide an additional dimension of feedback to help support interactions with virtual objects. Our recent Interaction SDK demo firsthand is another example of the impact immersive audio can have on a project. Let's listen to the audio in this experience. Listen to how the sounds of ambient objects fill the space and create a sense of presence. I really love how the sound design in this demo gives the player information about what they should do next. And when the player touches something, they learn more about it through how it sounds. Now, let's talk about how you can get started creating immersive audio for your app with the Audio SDK. Our goal with offering spatial audio in the Presence platform is to make integration quick, accessible, and intuitive. We have built in enough flexibility for you to craft the audio experience that feels right, while keeping things easy to use. If you are a developer with limited experience in audio, you'll find the SDK contains several easy-to-understand components, which integrate with and expand the functionality of Unity's native audio engine. If you are an experienced audio programmer or a sound designer in search of a powerful spatial audio or acoustic solution for your team's upcoming project, you'll be able to dive deeper and uncover the true potential of the Audio SDK. We've added several new audio features and will continue to expand the feature set in the future with more advanced control over spatialization and acoustics. We plan to provide SDKs that work with Unity and Unreal game engines, as well as audio middleware providers Wwise and Fmod. You can expect the Unity Audio SDK later this year, and then support for Unreal Engine, Wwise, and Fmod will follow after that. So keep an eye out on our Presence platform website, where we'll launch a public experimental release of the Audio SDK later this year. And check out other sessions on the Presence platform at Connect. We hope you feel inspired to leverage the power of Audio SDK to create a truly immersive experience.
Hi, I'm Courtney Phillip, Product Manager on VR Developer Success. Today, we're excited to talk with you about how to overcome some of the friction and challenges in your day-to-day Meta Quest development workflow, and share with you some tools and resources that will help accelerate your VR development process and help you build the highest quality product possible in the most efficient way possible. To start out, I'm going to give you an overview of our Developer Hub and some of our latest updates. Then, I'll hand it over to Ravi Dandu, who will share some tools to help simplify your developer experience. Finally, Rob Radke will walk you through our on-device automated testing. Now, some of you may already be familiar with the Oculus Developer Hub, or ODH. Today, I want to introduce you the rebranded MetaQuest Developer Hub. It's the same great tool that we released 2 years ago with some new exciting features that I'll share more about in a bit. The Developer Hub is a desktop app that is designed to streamline the MetaQuest development workflow and help you stay up to date on the latest Quest news, tools, and updates. It's available to install on both Windows and Mac. The Developer Hub offers a centralized place for you to manage your devices and all of your VR development tools. Our top-line goal is to make the VR development workflow simple and accessible by reducing friction and helping development teams iterate more efficiently. For those not familiar with the Developer Hub, I want to take a moment to show you some of the tool's key features. In the Developer Hub, you can learn about the latest Quest news and updates, manage your device with features like Guardian and proximity sensor toggles, or headset display casting, where you can also capture screenshots and video recording. You can also analyze your app performance, easily manage device files, and upload apps all in one easy-to-use tool. For more specific details on these Developer Hub features, you can check out our past videos by scanning this QR code. Now, since our 2.0 launch last year, we've continued to make improvements and launch new features to streamline the experience for common development tools. We added support for Link, which you'll hear more about from Ravi later in this session, so that you can easily enable and disable Link without putting on the headset. We've also added a section for code samples to the Downloads tab. Samples and showcases can help you build faster by providing code, assets, and integration pathways for some of our most popular features. Now, all of the samples available in GitHub are easily accessible and can be downloaded directly from the Developer Hub. We also invested in providing better support for the unique development needs of specific app types. So, for those of you that are building multiplayer apps, you can now test group launch directly from the Developer Hub. This feature eases the implementation and helps improve the reliability of group destinations, which enables people to easily join your apps together. Finally, we've added new video capture settings that give you the ability to select iView, video resolution, frames per second, and bitrate, so you can capture better video for marketing assets, or just make it easier to collaborate on art and design with video examples. Looking ahead at the new Developer Hub 3.0 and beyond, we're continuing to invest in the areas that will help remove friction for you and your team in your day-to-day workflow. We are focused on 3 main goals. 1, we want to improve your experience with distributing and testing builds. In our upcoming releases, we'll have several new features that will improve the build-upload process. Today, when there's a build-upload failure, you see a wall of text that's hard to digest and likely makes it difficult to identify the important information. We're fixing this by offering a more intuitive UI with specific information to help you determine the root cause of your upload failure and details on how to fix it. We are also streamlining the existing drag and drop workflow and helping you identify potential build upload violations before uploading. Our second goal is to continue reducing friction around switching back and forth from your computer to your headset and then back again during development. We're really excited to share that later this year, you'll be able to remotely control your Meta Quest device via keyboard and mouse while casting the display in the Developer Hub. Here's a quick preview. You can see here that you'll be able to use keyboard controls to move the headset rotation, as well as the cursor. You will also be able to use your keyboard to click with the cursor and engage with elements in the VR display. Our third goal is to improve the experience with performance tools. In Developer Hub 3.0, you can feel more confident that you're getting a clean read when doing performance analysis, due to a reduction in the performance overhead on connected devices. We will also be introducing a guide to help you better understand when and how to use the performance tools in the Developer Hub. Now, I'll hand it over to Ravi Dandu, who will talk about some other tools that can help improve your developer experience.
We are continually working to make your development experience better and more frictionless, so you can spend your time on building great content. Let me explain some steps we have taken to make your day-to-day experience for developing on Meta Quest easier. Here are 4 big points of friction we have heard from you. First, getting started with the SDK. Second, reducing build times. Third, debugging. And finally, putting on and taking off your headset. So let's get started with the SDK first. We are making improvements to our Unity package to make it easier for you to update and reduce your pain. We're working on shipping Meta Quest integrations via Unity Package Manager. It'll make the onboarding and package management process much more modular and stable. Modular by clear encapsulation of different SDKs. More stable updates by remote package synchronization. You can find out more details on the Developer Center. We are starting with experimental releases and planning for official release in 2023. Secondly, we are focusing on reducing build iteration time, which you have heard from you is a major pain point. Over the last year, we worked closely with both Unity and Unreal to achieve this. For Unity, we have reduced iteration time by 30 to 80% using just a few optimizations. First among them is addressables, which separate the asset building process from the code building process. By separating assets from code, the APK build is more than 50% faster. And when modifying remote assets only, you don't have to rebuild the APK at all, making it about 75% faster. These numbers are from the Unity Asset Streaming app that you can find in our GitHub repository. Of course, improvement will vary based on the compositions of your application. Our second improvement is script-only patch. You can patch a generated APK when you change code only. The script-only patch improved build times for reference app by 45%. So, if you're iterating a lot on code and not on assets, script-only patch is definitely for you. For Unreal on MetaQuest, you can save time for assets by using cook on the fly. Assets conversion from the development format to the platform format are delayed until after the game has been deployed, resulting in 60% faster builds. So, if you're modifying assets, don't have to modify code, cook on the fly, and then iterate in editor on the assets. If you're modifying code only, deploy compiled .so directly to the device is faster by 40%. Please use these enhancements to reduce build time. You'll be able to spend less time in the edit, build, test loop and spend more time on adding new features or enhancing gameplay. Okay, let's move on to improving debugging options with your favorite IDEs. Last year, we launched the VS Code extension that provides support for debugging native C, C++ code applications. And this year, we're supporting Android's game development extension, AGDE, on MetaQuest devices. So, if you're a game developer of PC VR games or you're used to developing with Visual Studio, AGDE allows you to keep the same IDE for porting and debugging to the MetaQuest platform. Finally, reducing the number of times you have to get in and out of your headset has been a goal of ours for quite some time. We have two solutions. The first is Link with PC SDK, which is now much more stable, giving you a more reliable testing experience. We're also making more improvements in the play, pause, play cycle. And you won't need to enable Link before loading Unity. So, by the end of this year, you should have a more convenient dev experience for desktop development using Link. The second tool is Meta XR Simulator, which makes it easier to do day-to-day development without needing to wear your headset every time. Meta XR Simulator enables you to test your app on desktop, choosing between MetaQuest 2, MetaQuest Pro, and Rift S. It can also simulate motion of your headset and the touch controller inputs through keyboard and mouse or an optional game controller. You can simulate important headset attributes like accurate field of view and correct display resolution for each device. Here is a demo of Meta XR Simulator with input simulation. This is still under development, so it can change before release. The window on the right shows the active input devices we are controlling: the headset, left controller, and the right controller. We can simulate inputs through a keyboard and mouse or an optional game controller. As you can see, we can easily move the headset, left and right controller separately. Or we can move all of them together at the same time. Here is the headset moving closer to the controller, and we can see the buttons being clicked. You still need to test on device towards the end, but Meta XR Simulator makes your day-to-day iteration so much easier. Meta XR Simulator will be available early next year, and pilot testing is this half. Now, to explain how you can leverage on-device automated testing so you can spend more time creating features and less time chasing down regressions, is Rob Radke.
From a theoretical standpoint, every software engineer knows the benefits of automated tests. They catch bugs early in the development lifecycle when they're a lot easier and cheaper to fix. And this is true across all domains. It doesn't matter if you're landing a rover on Mars or you're building a killer VR app for MetaQuest. And yes, contrary to popular belief, that does include game developers like you who want to scale their games up to a metaverse-sized audience. So why is it that so many teams skimp when it comes to automated testing? Well, the truth is automated testing is challenging. The tests take time to write, they take time to maintain, and they can actually become counterproductive if you don't constantly stay on top of them. I mean, a flaky test can be worse than having no test at all. Even worse, until very recently, MetaQuest headsets just weren't that good for running your tests. System dialogues would block your tests from running. The Guardian was hard to turn off. And good luck to you if you needed to reset your test device. Poof, there goes 3 minutes of your life clicking through the new user experience that you've seen many, many times before. Your feedback told us this was a major pain point, and we're pleased to announce that we now have a solution. That solution is MetaQuest's scriptable testing. Scriptable testing is a set of commands that allow you to do things like factory reset a test device, log in a test user, and disable features that could compromise your test. You don't have to put the headset on, and you don't even need to be physically present with the device. Scriptable testing can help you run your tests more reliably and without human interventions. Whether you have a single test device or a rack of 100, the goal is to save you time and money. Here's a great example. Big Box VR, the creators of Population One, have already started using scriptable testing in their automation lab. Since resetting a test device no longer requires putting the headset on, full device resets are substantially quicker. Even more importantly, engineers can now reset test devices when they aren't even at the lab. No need to drive across town anymore. Furthermore, since the commands are well documented and simple to use, Big Box was able to reduce the size of their test scripts substantially. Starting with version 44, MetaQuest's scriptable testing is built into the operating system, so it's naturally compatible with existing test frameworks, including Meta's AutoDriver, Unity's testing framework, and Unreal's Gauntlet automation framework. Check out the documentation and get started automating your tests today. Meta wants to help innovative and creative developers like you build amazing experiences for everyone in the metaverse. We want to provide the APIs, the tools, and the know-how to help you succeed throughout all phases of the development lifecycle. Follow this QR code to our developer documentation and get started today. Together, we can amaze and delight our users.
We know how important performance is for our developers. Rendering high-quality content at the resolution and frame rate that is required for a smooth VR experience is extremely challenging. This is why our teams at Meta focus a lot of time and effort into application performance so that developers can build the best VR applications for Meta Quest devices. Hey everyone, I'm Luc Charbonneau, a software engineer on the developer architecture team. And today, we'll talk about some of the performance optimizations that we've been working on in the last year. We'll present to you a new feature that we're really excited for our devs to get their hands on, eye-tracked foveated rendering, or ETFR, coming on our new MetaQuest Pro headset. We'll discuss symmetric FOV and give a quick update on application space warp that we introduced last year. We'll also go over some of the memory optimizations that we shipped for Unity Vulkan. And finally, Jimmy will present an update on some of the valuable tools that developers use for maximizing the potential of their applications. This includes some improvement to Perfetto, as well as RenderDoc Metafork, formerly known as RenderDoc for Oculus. But before we get to Jimmy, I'll hand it off to Ross, who's going to do a deep dive into our latest optimization, eye-tracked foveated rendering.
Hi everyone, I'm Ross Ning from the Meta XR mobile graphics team. I've been working on bringing new graphics features to VR for the past 4 years. You are probably familiar with FFR, or fixed foveated rendering, which renders full resolution in the center of the screen, often called the fovea region, and low resolution in the periphery. This provides substantial GPU saving for Meta Quest applications. Now with eye-tracked foveated rendering, or ETFR, we're pushing the boundary forward by moving the fovea region around to match where you're looking using eye tracking. Because the low resolution region is always hidden in your peripheral vision, we can now use more aggressive foveation maps, hence delivering more GPU saving. So here is how ETFR works at a very high level. First, we have the user's gaze computed from eye camera images. We then use the gaze information to move the high resolution region around. In order to do this, we're using the new Vulkan extension from Qualcomm called Tau Offset. With this extension, we can reuse the same foveation map, but simply move it around at much finer control. This avoids the flickering artifact in the traditional method, where we change the pixel density for each tile individually. In our ETFR pipeline, the camera sensors and the processing are fully synced to the rendering pipeline in order to minimize the latency between eye movement and the display time. The end-to-end latency measured in our UE4 application is roughly 46 to 57 milliseconds. Along with eye tracking gaze prediction, we're able to get a very good visual experience for all kinds of eye movement. One of the major benefits from ETFR is GPU saving. For example, the following diagram shows a perf comparison between FFR and ETFR in a UE4 test application. As you can see across all foveation levels, ETFR provides better GPU saving than FFR by using the more aggressive foveation map. But it's also important to note, perf and quality are always trade-offs. As a game developer, you are responsible for choosing the foveation level that best fits your content. We recommend to start at the lowest ETFR level and increase until you start to see some artifact in the preframe. One simple way to use the extra GPU saving is to increase the render target size, which improves the graphics quality in the foveal region, creating sharper and crispier images. Here is an example of what we measured in our UE4 test application. Let's say, if you were rendering with no foveation, default resolution, and MSA4, you might want to try ETFR level 1 at higher resolution, MSA2, which renders at similar GPU time but gives better image quality. Similarly, if you were rendering at FFR level 3, MSA4, you might want to try ETFR level 2 with MSA2. The GPU saving you'll get from ETFR will depend on your application's content, so make sure to profile your application at different foveation levels and render target size in order to determine which combination works the best for you. On the other hand, increasing the render target size isn't the only way to use the extra GPU saving. It's up to you to decide what to do with it. With ETFR, we also recommend turning on subsample layout for your application. This enables bilinear upsampling from low-resolution regions, removing pixelated artifact in your periphery. Now I'll pass it over to Luke, who will cover the engine integration for ETFR.
There are a few things to keep in mind while integrating eye-track foveated rendering in your application. Since some users might prefer the look of FFR over ETFR, it's a good idea to have an option for it in your application setting so that users can toggle it. It's also important to mention that some users might disable eye tracking entirely. In that case, ETFR will be disabled accordingly. And finally, since the eye tracking sensors are only available for the Meta Quest Pro headset, ETFR will only work on that device. You'll want to make sure that the device supports the feature before trying to enable it. With these three considerations, it's important to understand that whatever you decide to do with the extra performance gains might need to be disabled when eye-tracked foveated rendering is turned off. ETFR is really simple to integrate into your Unity or Unreal application, and our developer documentation has all the details. ETFR will be available in our V46 SDK for both Unity and Unreal Engine 4 and 5. Another feature we want to mention is symmetric field of view, or symmetric FOV. In the past, on MetaQuest, applications would render using asymmetric FOV to prevent rendering areas that are not visible through the lenses. By switching back to symmetric FOV, we're actually rendering a bit more than what's visible to the users, but we have two optimizations that makes it more performant than its predecessor. First, by using multi-view, which renders both the left and the right eye tiles at the same time, there's a higher chance that the content will be similar in both eyes when symmetric FOV is enabled. This results in a better cache coherency, which results in a better performance. The other optimization we do with the help of the fragment density map extension is to turn off rendering for tiles that are invisible to the users. You can see what it looks like here. The gains you'll get from symmetric FOV might vary depending on a few factors like IPD and even foveation levels. You might also see more gains when using complex vertex shaders and less in the cases where your application is fragment bound. Symmetric FOV is on by default for Unreal applications, and Unity devs can simply enable it in the Oculus XR plugin settings. Last year, at Connect 2021, we launched Application Space Warp, which can give you back up to 70% of CPU and GPU time. At a high level, what Application Space Warp does is synthesize every other frame for your application from the information of the previous frame. You render your app at half the targeted frame rate. So if you're aiming for 72 FPS, you'll render at 36. In addition to the iBuffer, you'll also need to render a motion vector buffer and a depth buffer. And with that information, our system is able to generate the next frame for you. Developer adoption of Application Space Warp has been fantastic, and we continue to improve the tech based on your feedback. We're currently working on some showcases so that developers can easily see how good Application Space Warp looks and how to make the best use of the feature. And finally, let me tell you how we've been improving memory for applications using Vulkan in Unity. About a year ago, we noticed that using Vulkan for some applications resulted in much more memory usage than when using GLES. After months of efforts, we're happy to announce that we've made huge memory wins on Vulkan. In fact, optimization saved over 1 gig of memory for one of our AAA developer projects. We think most Vulkan Unity applications will benefit to some extent from these optimizations. Be sure to be on the latest Unity 2021 LTS version to benefit from those savings. With all the graphic optimizations we've made in the last couple of years, like eye-tracked foveated rendering, symmetric FOV, and Application Space Warp, we believe that Vulkan is becoming the graphic API developers should be using when developing for our platforms. And with the huge memory optimizations that we've shipped recently in Unity, we're making it easier for developers to make the switch to Vulkan. I'll now hand it off to my colleague Jimmy, who will go through some updates on the tools that will help you tweak your application's performance to its best.
Before working at Meta on VR developer tools, I worked in the video game industry on AAA titles for 11 years. Hi everybody, I'm Jimmy Lee, and I'm here to tell you about the latest performance tools for the MetaQuest platform. My team's goal is to improve VR development workflows and tools with an emphasis on high-quality video game production. Today, I'll be showing some of the new tool changes that will be coming your way very soon. You might already be familiar with some of these tools, but I'm going to demonstrate some new tricks you can perform to get deeper access and more information from your device. We introduced the Performance Interface Library, or PIL, 2 years ago. PIL grants some of the most popular tools on our platform, such as OVR GPU Profiler, Render.Metafork, Metafork, and Perfetto, the ability to perform GPU traces. A GPU trace captures detailed, low-level information on the work your application sends to the GPU. And it can reveal performance inefficiencies or bottlenecks. PIL currently offers 3 different types of traces. First, real-time monitor that gives a global view of the system metrics. Second, render stage trace surfaces low-level information related to the different stages of the mobile GPU pipeline. Render stage trace can also operate in low overhead mode, which reduces performance overhead by omitting some parts of the trace data. And finally, draw call trace that pulls low-level hardware counters while disabling hardware concurrency in order to report per draw call metrics. Available in V46, applications will no longer need to declare internet permission in order to participate in a GPU trace. Furthermore, you will be able to see the Oculus VR runtime service among other services in the GPU trace as well. Let's take a look at how to do this using Perfetto. Before launching your app, enter the following ADB commands in a shell. ADB shell OVR GPU Profiler -E will put the device in detailed profiling mode. Then, we will use two ADB force-stop commands to stop two system services. When a system service is stopped, it'll restart on its own. Then, simply launch your application and record using the new data source shown here. The change of data source is necessary in order to handle large amounts of GPU data. The change also improved the GPU track UI dramatically, making it much easier to read. Now, if you already have tools set up to record GPU trace through a track event configuration, there is no need to update because track event GPU trace will continue to work. And the improvements are retroactive so that you can enjoy the UI improvements and system service participation using track event configurations as well. In just a moment, we're going to show you what a GPU trace with system service participation looks like. But before we do that, let's also take a look at the Perfetto one-button trace from Oculus Developer Hub, or ODH. We have made significant performance improvements to ODH, and it'll really help simplify your Perfetto workflow. Let's perform a Perfetto GPU trace using ODH. First, we need to enter these ADB commands before launching your app. Then, launch your app. After entering the ADB commands, open ODH and navigate to the Performance Analyzer. Click on the ellipsis and select Perfetto Settings to set the Perfetto trace configuration. This opens up the trace configuration window. We have made changes to allow your Perfetto trace to allocate a dedicated amount of memory for the purpose of GPU tracing. This is important for the reliability of your trace, as GPU traces can consume large amounts of memory, and that can lead to data loss on other data sources for your Perfetto trace. With the trace configuration window handling the setup, there is no need to study the Perfetto syntax. You can simply toggle GPU render state trace to enable GPU tracing. You can also toggle high precision GPU render stage tracing. Doing so will tell Perfetto to gather more information at the expense of profiling overhead. Click Save to save the configuration. With the configuration saved, click on Record to start the trace. The default configuration will perform a trace for 5 seconds. Once the trace finishes, ODH will automatically open the capture in the browser. You notice that the GPU tracks are now placed at the top. The GPU tracks also show the owner process in parentheses. To enable Perfetto instrumentation in Unreal or Unity, make a debug or development build of your project. You get detailed thread execution from your application shown as a collection of thread tracks, grouped under a process track. You can use the star icon to pin the GPU and thread tracks to the top. That way, you can clearly see the execution dynamics of your app on the device. Let's zoom into the GPU tracks and look at how this app interacts with VR runtime and Guardian service. Here's one frame worth of rendering, and we can see that there is a preemption during the execution of one of the bins. With the GPU tracks placed adjacent to each other, we can now see that this GPU work was preempted for the execution of the VR runtime. Looking over to the thread tracks, we can see how one frame starts from Unreal's game thread, and then the render thread takes over. Then the GPU work begins. While this is happening, the time warp thread from VR runtime performs work on the left and right eye. This results in 2 GPU preemptions you see on the application. Finally, when the application's GPU work finishes rendering, the fence checker releases the lock so the next frame can begin. The entire journey is also visible over here in the CPU core section. This section shows the physical core allocation of threads from all processes. We can see that the render thread here is executing on CPU core 4, and after a short while, continues execution on CPU core 5. CPU 0 to 3 represents the silver cores. CPU 7 is the gold prime or platinum core. And they are reserved for our system softwares in order to produce a judder-free view for VR. CPU 4 to 6 are the gold cores, and your app has full access to them. By inspecting how your app executes with other processes and services, you will gain a deeper understanding of our platform and make more accurate diagnosis. Now, let's look at a tool that works very differently from Perfetto. Instead of instrumenting the app with profile markers, which can result in performance overhead, SimplePerf relies on the performance monitor unit that monitors performance events on the processor. When an event triggers, SimplePerf samples the program counter and looks up the executing function. By randomly sampling over some periods of time, performance overhead can be limited to an acceptable level. The accumulation of random samples forms a histogram of function calls, which can then be used to calculate the event frequency of all function calls from the app. Available now through the Android NDK, we can use SimplePerf to perform sample-based profiling. Under your NDK directory, there is a folder called SimplePerf, which contains a number of Python scripts. While your app is running, use the app profiler command to initiate the sampling. You need to specify the package name of the APK you want to sample. SimplePerf will only sample the hardware event CPU cycles by default. If you want to sample different types of events, you can specify the sampling event types via -e. By sampling different types of hardware events, you might discover different inefficiencies in your app. After the sampling is done, run the report HTML command to generate an HTML file containing the reports of the sampling session. The command will also open the report in the browser when it's done. A SimplePerf report can show us the distribution of time spent in the form of a pie chart based on the events that we sampled. The time spent can be sorted by process, threads, libraries, or functions. To see function names, SimplePerf will need to have access to symbols for the sample functions. The report can also display a function flame graph for each thread. The most expensive functions are stacked at the bottom. Please keep in mind that sampling-based profilers need to take large amounts of samples over multiple frames. As such, it is not suitable for investigating sudden performance spikes within a few frames. Besides the function call statistics we get from SimplePerf, we can now also get shader statistics thanks to our collaboration with Qualcomm. Available now through the Vulkan extension, Pipeline Executable Properties, you get 19 counters to help you optimize your Vulkan shaders. Nobody likes to write extra code, and you don't have to with RenderDoc, since it implements the Vulkan extension right in the shader module panel. With the 19 counters we've got, you'll be able to figure out how your shader is doing. Now, let's take a look at how to access these shader stats in RenderDoc. First, open your RenderDoc capture. In the event browser, navigate to the draw call you are interested in. With the draw call selected, check out the pipeline state panel. Click on the vertex shader stage, and then click on View. In the disassembly type drop-down list, select Pipeline Executable Properties. We will then be shown shader stats for the vertex shader of the draw call. Similarly, if we do the same thing on the fragment shader stage, we will get shader stats for the fragment shader of the draw call. We can also do the same on compute shaders as well. We can see here what the shader stats look like from RenderDoc. A smaller count value generally correlates with better performance, but the optimal value will depend on your artistic vision and aesthetic goals. For more information on RenderDoc or each of these specific shaders, check out our documentation in the Developer Tools section on our website. Another important factor that can affect your app's performance is the presence of Vulkan validation errors. Now, RenderDoc can enumerate these errors when opening a Vulkan capture. Simply enable API validation on replay when opening your capture, and a list of Vulkan validation errors will be listed in the errors and warning panel. But if you want to check for Vulkan errors over the span of an entire program execution instead of a single frame, then you use the Vulkan validation layer via setprop. Simply use the adb command shown here. You have to replace your app's package name in place of the bolded package name. After entering this command, simply launch your app. The errors or warnings will be shown in Logcat. You can use the tag validation to filter for the Logcat output. Did you know that you can also use RenderDoc to debug and profile WebXR applications on the MetaQuest browser? RenderDoc support came back recently on OS Update v46. So you can now launch the browser from RenderDoc and make captures of your WebXR application. Before we begin, we need to enable RenderDoc support in the browser. Put on your headset and enter Chrome://flags in the MetaQuest browser's address bar. Then search for RenderDoc Immersive Mode support and change the selection to Enabled. Then click on Relaunch for the change to take effect. Back to the RenderDoc client's Launch Application panel, toggle Show Hidden Files and select com.oculus.browser for the package and default activity for the activity. Click on Launch and RenderDoc will launch the browser, and then you can load your URL for capture. After making a capture, you'll be able to debug and profile your WebXR capture like a native capture. That's all for today's tools update. Look, we know it's a lot, and that's because we have made huge investments in the Vulkan optimization and performance tooling, and more is yet to come. We hope you leverage the optimizations we have presented today and use the tools we have demonstrated to verify your performance improvements, because together we can create compelling and performant experiences and help build a better metaverse. To learn more about everything we have talked about today, please check out these links. If you have questions, our developer forums can answer them. We'll see you next year.
We've been amazed at the incredible experiences people have built in Horizon Worlds. The process of creating a world with your friends, in real time, in VR, is really special, and it's only getting better. I'm a part of a team that is passionate about creating these types of experiences and helping other creators unlock the power of Horizon Worlds. Hi, I'm Vu, and today a few of my friends and I are going to create a quick demo. Along the way, we'll show you how we use Horizon creation tools to build this world. For this demo, we're going to create a rooftop poker game where you'll need to navigate the environment to collect the most coins. You'll be able to dress your character, jump and swing around, and compete with your friends. We'll also be adding some scorekeeping, a leaderboard, and achievements to tie it all together. When we're done, we'll publish the world so that everyone can jump in and try it out. We'll also provide a template version of the world for editing so you can dive in deeper to understand what we did. Let's get started.
We are standing in what is essentially a 3D blank canvas. We have a bunch of ideas for what we want to do, and in Horizon Worlds, we have the tools to bring that vision to life. Hi, I'm Eugene, and I'm one of the collaborators on this project. I love to build things, and creating in Horizon Worlds lets me quickly and tangibly turn my ideas into an immersive, interactive, shareable experience. With these tools, there is a freedom and physicality to the creation process that I haven't experienced in any other digital medium. In addition to building from scratch, I can also pull pre-made items out of the asset library. Since we'll be making a cityscape to play in, let's see if I can find a few buildings for our world. You'll notice that some of the items in the asset library have complex and unique shapes you won't see in the build menu. That's because we've been adding assets that were created using tools outside of Horizon Worlds to give creators more options. We've also already seen folks incorporating them into their worlds with amazing results. You'll see plenty more items like these as the asset library continues to expand. And that's not all. I'm happy to announce that we're working on enabling creators to import triangle mesh items built outside of Horizon Worlds into their personal libraries. That means that you will soon be able to import assets you've made on other creation platforms directly into Horizon Worlds. We know lots of creators love building with other digital design tools, and we want to make sure that your worlds reflect your talent and your personality. Oh, here's a good one. That's great. But let's customize it a bit. When you pull an item out of the asset library, you can modify it any way you see fit. The other great thing about the asset library is that it lets you save items you've previously made. So, anything you build or any script you write can be saved into your personal library, and you can easily reuse it in any other world you're building. It's a massive time saver. Okay, that's a great start, but we have a whole city to populate. Cue time lapse. To build out our city map, we're using a combination of assets from the asset library as well as our own personal creations. Since this will be a parkour world, we're adding lots of verticality with ledges to jump from and construction cranes as anchor points for swinging. We're really leaning into that sense of scale and freedom that VR does best. When you're creating a world, every aspect from the general layout down to the tiniest details are in your hands. One of my favorite things about Horizon Worlds is the ability to create something and then immediately feel like you're there. So you can make a model in your hands and blow it up to the size of a skyscraper and actually go stand on top of it. And here we are. Hey, Fu, can you get over here?
It looks a little far, but luckily, one of the newer features we've released allows creators to make scripted player movement. This means that you can build some really fun movement-based mechanics. To help show you what I mean, we'll start with a simple jump pad for crossing these building gaps. Here's a jump pad that I saved in my personal library. Let's try it out. The jump pad launched me, but it looks like I fell a bit short. Good thing I can inspect and change anything in the world, including this jump pad. Let's take a look at its script. This is a line in the script that changes the player's velocity and launches them into the air. It looks like there is a variable we can just change to increase the force. Let's go ahead and do that. One of the coolest things about Horizon Worlds is that it lets you jump back and forth instantly between editing and testing, even while others are collaborating in the world. Let's see if this works better. Nice. Perfect. We'll put these jump pads all over the world to make it easier to navigate. That jump pad was a simple example, but scripted player movement allows for a lot of powerful mechanics like flying, climbing, and swinging. All kinds of stuff that feels thrilling in VR and opens enormous gameplay possibilities. For this world, we also want to give players the ability to swing around these buildings and reach different areas. I think something like a grappling hook could work really well. We could build one from scratch, but I have here in my asset library something I made earlier. This asset has a script that uses a new update event to modify a player's velocity each frame. Let's give it a swing! Woo! That was awesome! Now we have a great movement mechanic for this world. Let's enhance the experience with the help of my friend Yanis. Yanis, how do we make this world feel more alive?
When building a world, an artist creates what's in their mind's eye using visual elements, color, and design to tell the narrative. A sound designer does the same with sonic elements, frequency, and mechanics. I'm Yanis, and I specialize in helping creators use our audio tools to make their worlds come to life. So, how do we decide what sounds to include and how should they be heard? Let's look at our world. While we're up high on the rooftops, we'd probably expect to hear some wind sounds up above and a busy city below. So I've placed specialized sound gizmos around the world to create the sonic environment. By adding a city ambience below, this helps to emphasize movement through the verticality of the world. However, we can do a lot more than that. This is an experience that emphasizes movement and speed, especially with the grappling hooks. So we want to make sure that we capture the emotion of swinging through the air. To do this, I'm going to assign each player their own wind sound gizmo. This sound helps provide a sense of environment and speed. So to ensure each player only hears their own wind sound, I am locking the gizmo to the player's head and will give it a small auditory radius. To give the player a dynamic sense of motion, I have attached a script to drive the wind's pitch and volume based on that player's velocity. In an immersive environment, dynamic feedback like this can have an enormous impact on the player's experience. Let's take a listen.
The world sounds so alive now, Yanis. Thank you so much. Let's check in with Eugene next. What are you up to?
I'm working on player outfits.
Cool.
Everyone loves customizing their avatars. It's fun, it's expressive, and it adds a layer of immersiveness into the world. I mean, come on, who doesn't enjoy that? Now, I want to make sure that there's a lot of options just like this for each player. But that could really start to add up, especially when you factor in other objects like scenery and effects. This is where another new feature, asset spawning, is a total game changer. With asset spawning, you can load assets directly from the asset library into the live world as needed. To show you how this works, I'm going to use this fashion station asset. This is essentially a clothing rack that lets you cycle through and equip various items. None of these are preloaded in the world. Instead, the station dynamically spawns each hat, each pair of glasses, or any other wearable item. If the item isn't equipped, the script deletes it, saving on capacity. This way, you can have lots of options for all your players without breaking the capacity bank. Now, I've already saved the dino helmet I made into my personal library, so I can actually delete these. And now I can connect the saved asset to the spawning script. Awesome. This is just one example of asset spawning. You can use this powerful feature to spawn other game elements like player HUDs or even procedural environments.
Now that we have our environment, fun movement mechanics, great audio, and some personalization, I'm going to add some structure to the world. The asset library isn't limited to just models and props. You can also store complex systems. I created a coin collection game earlier and saved it into my personal asset library. This asset includes all the scripts and objects needed for the game to function and should be easy to integrate into this world. For this game, players compete to touch the coin the most times before time runs out. Each time you touch the coin, it gives you a point and then moves to a new random location in the environment. Let's go ahead and make the coin move around our map by duplicating these boxes around the environment to mark different places the coin can move to. The game should be ready to go. Next, I want to make it so people have a reason to come back and play over and over again, and feel rewarded for their efforts. To do that, we can add leaderboards so players can compete with one another for the top spots, and achievements to give players goals and a sense of progression. We've made it easy to set up leaderboards and achievements using the Systems tab. Next, I just need to modify some of my scripts to use my setup. And finally, place the appropriate gizmos into the world. With that, let's test out the game.
So many points.
That was just a few of the features that are available right now. There's a lot more that we didn't have time to talk about, like precise hand physics and dynamic lighting. You'll be able to try it all out when you start building.
We've titled this world City Parkour, and it will be available tomorrow for you to check out and play. We're also providing a customizable template version that you can edit.
We hope you enjoyed this overview, and I can't wait to see what you make. Thanks for
Thanks for watching.
Am I early?
Hey, Vu, what did you want to show me?
Check this out.
That's great! How did you do that?
Hey everyone, you've reached the end of this track, but there is still so much more to come. You might actually have time to watch some of the other sessions that are finishing up, so just head back to the Reality Labs Facebook page or pop into one of the other locations within Meta Squared. Karen, were you able to catch anything?
Yeah, so I checked out the creator journey session because I actually already follow all of them on Instagram, and I've used their effects before. These effects, they're some of the most mind-blowing, innovative, creative stuff I've ever seen. And what really stood out to me was when they spoke to how they got started and how they started from really simple concepts and even felt insecure in the beginning. And then seeing how they evolved from that to become as impressive as they are today. I think that's just so encouraging for anyone who wants to get started in all of this.
It's so true, and I'm always awe-inspired by the creativity and the perseverance of this community. It makes the future even more exciting, which is yet another reason why everyone should stay tuned for our final bit of the day. Carmack Unscripted will be live broadcast at 2:30 p.m. Pacific from Meta Horizon Worlds. Now, to those already in the metaverse, head back to the outdoor screen in Meta Square, and while you wait, feel free to continue to explore, network, and chat with other attendees and discover more of Meta Square. Now, to those on desktop or mobile, grab a quick bite, grab a drink, get some coffee, get some tea, but make sure to stick around on the Reality Labs Facebook page as our time with Carmack will start shortly. You do not want to miss his unfiltered take on the future of technology, so we'll see you right back here very soon.